How's it going, everyone? Welcome back to a video that I have so that we can get a little bit more practice in before the next time we get together. So this discussion is going to be on subatomic particles and how you can figure out how many protons, neutrons, and electrons are in a given atom. I've built a little table here that looks a lot like the one that we did last time we met, but really the things that I want you to focus on in this one are the mass and the charge of each of these subatomic particles. So the first thing to think about is that the protons have a positive charge, neutrons do not have any charge, and electrons have a negative charge. The other thing that we'll notice is that electrons and protons have the same charge as each other, just in opposite values or directions. So we're going to label it -1 and +1. The next thing we're going to consider is that protons and neutrons have a lot of mass in comparison to electrons, but they're about the same mass as each other, so we call them 1 and 1. And even though electrons do have mass, every bit of matter has mass. It's so small in comparison to protons and neutrons that it's functionally 0. So I'm going to label it 0. Just know that no actual matter doesn't have mass. It all has mass. If it doesn't have mass, it's not matter. Okay, so you might have seen these abbreviated in this way, or our proton being abbreviated as like a P+, a neutron being abbreviated as an N with a little 0, and an E being abbreviated as an E with a minus on it. And that's one way that we can shorten the names of things, and that's going to be how I refer to things from here on out. So anytime you see P+, N0, or an E-, you know that I'm talking about protons, neutrons, and electrons. I'm going to recopy everything from the previous slide over here. And there we go. Awesome. Okay, so let's talk about where we go next with this information, the periodic table. Every entry on the periodic table is going to have 3 things: the atomic number, at least an abbreviation of whatever element you're dealing with, and then the average atomic mass. So hold on, I'll draw those for you. Right here is an image of like a square from the periodic table for the element beryllium. The atomic number is 4. The abbreviation is going to be Be, and at the bottom we have the average atomic mass. Well, why do I call it the average atomic mass? So we discussed this a little bit last time we met, but when I refer to the average atomic mass, what I mean is that it is the average mass of all the isotopes of that element in existence. So when I look at this beryllium entry, I see 9.0122, which means that the most common isotope of beryllium in existence on Earth is 9.0 in atomic mass, because I can't have 0.122 or 0.0122 for a neutron or a proton value. I have to have at least one of them. So anytime you're dealing with this, unless I specify otherwise, you should just round. We would round down to 9 in this example. So for this specific atom, what I'm asking you to tell me is what number of protons, neutrons, and electrons am I going to find? And to be able to answer this question, I'm going to tell you that it is a neutral atom of the most common isotope. So when I say something is a neutral atom, that means that my charge is going to be 0, which means that my number of protons and electrons has to be the same. Remember, going back over here, that my protons have a charge of +1 and my electrons have a charge of -1. And my neutrons don't have any charge at all. An element is defined by its number of protons. So if I have fewer or more protons than 4, I'm not dealing with beryllium anymore. I'm dealing with something else. So what that means is if I'm asking you the number of protons in beryllium, your answer would be the same as the atomic number. So I've went ahead and I filled in 4 for the number of protons. Remember, if I change the number of protons, it's not beryllium anymore. The next thing you need to remember is that if it's a neutral atom, basically anytime you hear me say atom, I'm talking about a neutral atom in terms of charge. That means that the number of electrons and the number of protons are going to be the same. So I have 4 protons and 4 electrons. How do I figure out how many neutrons I have? It's a matter of mass. My mass number is always going to be equal to the number of protons plus the number of neutrons. Remember, my protons and my neutrons have mass, and my electrons have so little mass in comparison that I don't count them. So to find out what I have, I fill in the mass number, which in this case is going to be 9, because remember, I'm rounding down or up as necessary to get a full number or a whole number. I've determined that the number of protons is going to be 4. And then what I need to do is I need to solve for n. I use some algebra and determine that n is going to be equal to 5. So this atom has 4 protons, 5 neutrons, and 4 electrons. That's it for this video. I'm going to have a couple of practice questions for you on this and a couple practice questions on the next other videos.